A deck of cards is a great example of probability. Let's review some of our probability skills using a deck of cards. Each deck of cards is split into 4 total suits. The suits are spades, hearts, clubs, and diamonds. There's 13 cards in each suit. That means there's a total of 52 cards. 52 cards, 4 suits, 13 cards in each suit. These are important and common numbers when we're looking at the probability of cards. So altogether there's 13 cards, or hearts, 13 diamonds, 13 clubs. There are 4 of each card in the deck. That means there's 1 of each type of card per suit. So altogether there's 4 fours. There's 4 of hearts, 4 of clubs, 4 of diamonds, 4 of spades. How many jacks are there? There's 4. There's 1 jack of hearts, jack of clubs, jack of etc., etc., etc. Same thing with kings. There's 4 kings in the deck. Let's look at the probability with cards. What's the probability as a fraction and a percentage of being dealt a 5 card? So altogether we know there's 4 5 cards. So that's total 52 outcomes, 52 possible cards in a deck. 4 of them, because 4 5 cards in a deck. So that's a total of 4 over 52. If I simplify that down, that's a 1 and 13 probability. To turn that into a percentage, I'm going to divide 1 divided by 13 and move the decimal over 2 places. That's going to give me a 7.7% chance that you'll be dealt a 5. What's the probability as a fraction and percentage of being dealt a card in the heart suit? Well, we know that there's 52 cards altogether, 4 suits. So if I divide 52 by 4, I get 13 cards in each suit. That means that there's a total 52 outcomes. 13 of those outcomes, 13 of those cards are hearts. So I'm going to find the probability, events over outcomes, 13 divided by 52. I'm going to simplify, find the factors of 13. It's prime, so it's just 1 and 13. Remember, prime numbers does not mean it can't simplify. It's less likely, but it still can simplify. Always check. 52 and 13 divided by 13 gives me a probability of 1 in 4. I'm going to turn that into a percentage by doing 1 divided by 4. So numerator divided by denominator gives me the decimal version. I can move that decimal over 2 places to the right, which is just like multiplying it by 100 to get 25%. So I have a 1 in 4 probability or a 25% probability. That's how likely I'll be dealt a heart. On your own, try the next 2 problems. When we start dealing with cards being pulled in order, we need to look at multiple choice. Now, multiple choice, we looked at 2 scenarios. In this case, one scenario will be putting the card back in the deck. We're not changing the total number of cards. We're not changing the total events within that category of cards. Nothing about the probability changes. The other scenarios where you take the card out or you deal it out to someone else. In these scenarios, you're going to find the original probability of each event. So if I need to find the probability of being dealt a face card and then being dealt a 9, so altogether, if I look at my card matrix up top, there's a total of 12 face cards out of 52 total cards. There are 4 9s out of 52. So I'm going to multiply my 2 probabilities together. This is just like when we deal with an AND scenario. So 12 times 4 gives me 48. 52 times 52 gives me 2,704. In order to simplify that, I'm going to find the factors of the smallest number. So I'm going to take 48, 1 and 48. 48 divided by 2 gives me 24, a whole number. 48 divided by 3 gives me 16, a whole number. 48 divided by 4 gives me 12, a whole number. 48 divided by 5 gives me a decimal. 48 divided by 6 gives me 8, a whole number. 7 gives me a decimal. 8's on the other side of the mountain. So I'm going to go with 16 because I would check 2,704 divided by 48, get a decimal. Divide by 24, decimal. Divide by 16, decimal. Remember, stay sharp on those simplifying skills. Fractions do not go away. They just change into different forms like probability. So I simplify that down to 3 in 169 probability. In the next scenario, we want to find the probability of being dealt a heart and then being dealt a red card. Well, we know that heart is a suit. There's 13 cards in each suit because we're taking 52 divided by 4. So that's 13 in 52 total cards. There's 26 red cards because half the deck is red, half the deck is black. So there's a 26 out of 52 probability. Now, if I were to multiply these two fractions or these two probabilities together, I would get really large numbers, which makes simplifying very challenging. So if I simplify beforehand, it might make life a little easier. I know that 13 out of 52, that's a quarter of the deck. That's one whole suit. So that's a 1 in 4 probability. 26 out of 52, well, that's half my deck because half the deck is red, half the deck is black. So I'm going to multiply by 1/2. This makes the numbers a lot easier to deal with. You'll see a lot of the same fractions or same probabilities when they're simplified when you're dealing with cards. 1 times 1 is 1, 4 times 2 is 8. I have a 1 in 8 probability. In these scenarios, the card was put back into the deck. That's why the denominator is always 52. The total number of outcomes is always 52. If we keep the card out of the deck, so we're not replacing the event, we still start the same way. Find the original probability of each event. So we want to find the probability of being dealt a face card and then being dealt a jack. In this case, the card is not being put back in after we're dealt the face card. So to begin with, there's 12 total face cards out of 52 total cards in the deck. Every time that we remove an event, subtract 1 from the total outcomes in that specific event. So in this case, we have 1 less face card and 1 less total outcome. So that first probability was 12 out of 52. There were 12 total face cards. We took away 1 face card. There's 4 jacks left. There's 51 total cards left. Last step, we're going to multiply these two together. 12 times 4 gives me 48. 52 times 51 gives me 2,652. You can always then try to simplify after you've completed multiplying. So I'm going to find the factors of the smallest part of the fraction. Then I'm going to find which of those factors divides evenly out of the denominator or numerator, whichever value I didn't choose to find the factors of. Divide top and bottom by 12, I get a 4 in 221 probability. In this next scenario, we're looking at the probability of being dealt a heart and then being dealt a 5. So if we're dealt a heart, there's 13 total hearts out of a total deck of 52 cards. So that's 13 in 52. Now, assuming we're not being dealt the 5 of hearts, there's still a total of 4 hearts left in the deck. But there's only 51 cards because we took that first heart out. So we have 4 in 51. Remember, the 52 to 51, that changes because we're removing 1 card. What's the probability of being dealt the heart, then the 5? We need to multiply those together. 13 times 4 gives me 52. 52 times 51 gives me 2652. I'm going to simplify. I'm going to find the factors of 52. And then divide those factors from 2,652 to find which one simplifies or which one gives a whole number first. Divide top and bottom by 52. I get 1 in 51 probability. On your own, try the last scenario. We'll check it in class.